Well, good morning, Algebra 1 students. Today we are going to be on page 412. Page 412. We are doing lesson 98, which is the distance between 2 points. Yes, I am skipping, well, we did lesson 97 last time, and you worked on the actual assignment of 96. Now, if you recall, when we did the Pythagorean Theorem, if I draw a triangle like so, and ignore the actual measurements that are showing, but if I said these are the measurements, we can find what C is by doing C squared equals 4 squared plus 7 squared, or that C squared equals 16 plus 49, C squared equals 65, C equals the square root of 65. If you recall doing that. We can use the Pythagorean theorem then to help us find the distance between 2 points, which is the first exercise that we are going to do today. All right, so if I give you a triangle that was at, give you the distance between 2 points, a triangle that was on 3, -4, I can show you 3, -4, so that's 3, -4. The other point at -5, 2. So -5, 2. We could find, we can use the Pythagorean theorem to find the distance between those 2 points. And what we would do was we show the length. So if this is our hypotenuse, the 2 points, how do we find the distance? Well, let's turn this into a triangle. So we'll move on the x-axis, try to get this straight, all the way, as straight as I would have liked it, to where the other point is, and then we come down the y-axis to meet the points, and we make a triangle. Okay, so if we call this line D, we can find the other two shapes. So we can say D squared equals, this is 8 squared plus 6 squared. Otherwise, D squared equals 64 plus 36. D squared equals 100. Square root of 100 is 10, so D equals 10. That's one way we can find the distance between 2 points. Certainly using the Pythagorean theorem, which is what we learned when we did lesson 97. There's another thing that we can do as well to help us find the distance between 2 points, and that is using the slope formula. So let's clear the screen, and I'm actually going to get rid of the graph at this point because we could show the distance formula without using what we just did. And we can come back to that screen in a moment to prove it. All right. So the distance formula looks like this. If you're given 2 sets of coordinates, we were able to figure it out. Okay, so basically, if I gave you the coordinates -3, 4, and 5, -2, that should sound familiar. Actually not, but if I gave you those 2 points, we'll be able to find it. And this slope formula works like this. For the first point, we'll call this P1. For the first point, there's an X and there's a Y, and we're labeling them as 1 with a subscript just so that we can keep them organized. And if we call the second set I gave you P2, then I can write P2 equals X2 and Y2. All right? Just labeling, that's all I'm doing. Well, to find the slope, I can do this a little more carefully, and the formula goes like this. M equals y squared minus y1, y squared, y2 minus y1, and x2 minus x1. Okay, so using that formula that I just put up to find the slope of the line, the slope formula, we can plug in the numbers. So if I'm using that formula, let's Let's get it all set up. All right, so m equals, and then this time, let's plug in our correct information. We have -2, that's our y2, minus 4 over 5 minus -3. Right, as you can see, I have my y2, which was -2, and I have my y1, which is +4, and my over my x2, which is 5, minus our x1, which is -3. And I got my slope formula. Now if I solve it, I get m equals -2 minus 4 is -6 over 5 plus 3, which is 8. So I can reduce that -6/8 to equals m equals -3/4. Now what's handy about the slope formula is if I were to rework that problem, the exact same problem that I just had, I would have m equals, now this time I'm flipping my points, so now I'm going to trade my P1s and P2. So what if, let's clear some stuff so we have some room to work. Being slow, huh? My computer. Now, let's do something a little bit different. Now, what if this first one was P2 and the second one was P1? Okay, so what would that do to what we just did? All right, let's find that out. So now, let's take that same formula, but now we have 4 minus -2 over -3 minus 5. You know, when you do this, you get m equals 6, because 4 plus 2 is 6, over -3 minus 5 is -8. What do you end up with? -3/4, which is where we were the very first time. So that gives us the slope of the line, and with the slope of the line, you can actually find the distance between 2 points. All right. So hopefully you don't have any questions, but really it's as simple as what we just did. So if I go back to the first thing we did, if I were to find the distance between 4 and -2, okay, here's 4, -2, and -4, 4, -4, positive, -4, -4, there we go. Here's my line, it's 2 up, and it is 1, 2, 3, 4, 5, 6, 7, 8 over, what's that distance? What's that hypotenuse? Well, what is 2 squared plus, what did I say, 8? 1, 2, 3, 4, 5, 6, 7, 8. What's 8 squared equals d squared, which is, I'll call that d again, 4 plus 64 equals 68. And then that'll be the square root of 68. Oh, the screen's doing something weird. Not sure what's going on, but get this figured out. All right, so we got the square root of 68. Now we probably should simplify that. If I were to simplify that, I can get, oh, lost my pen again. If I simplify that, I can get 4 times 17. 17 times 4 is 68. So, and 17 is a prime number, but 4 is a square. So square root of 4 is 2 times square root of 17. And I just found the distance between those 2 points easily enough. So something that I can work towards to solve. So today we did the distance formula and we did slope of the line. Please make sure you have read through this whole lesson, all of lesson 98, and you can work on 1 through 30. Thank you. We're not.